Hey everybody, Jeff Scott here with you again. Thanks for joining me. It's been a while since I posted any new content, but I'm really excited about this content we're going to talk about today, and that is the concept of the cytokine. Whenever you hear the word cytokine, I want you to immediately think immune system. Okay, so cytokines encompass a large family of smaller peptide molecules, very short half-lives that allow cells, first of all, allow cells within the immune system to communicate with each other and to coordinate with each other, but also allow cells, non-immune cells, to communicate with their local surroundings and adjacent cells, but also communicate with the immune system. So these are topics, these are molecules that are so important for you physicians out there, or you, if you're a prospective patient who's just interested in learning more about regenerative medicine, you've got to understand what cytokines are, because getting control, modulating the immune system is absolutely a critical function and absolutely necessary for the success of any regenerative therapy. So understanding cytokines, what they do, how they function, and ultimately how they participate within a regenerative formulation to potentially change the phenotype of your body and to start getting a handle on pathology. It's very important to understand this term cytokines. So we're going to move into a presentation right now, and I'll see you on the other side. All right, so cytokines, I know this first slide has a ton of terminology on it, but it's important. Nomenclature matters. So I want you to understand, when you hear various terms, you're going to say, oh, okay, that's a cytokine, right? So that means it participates in the immune system somehow. Even if I don't know exactly how, I just know that that's immune modulatory to some degree, either pro or as an antagonist. So cytokines have several families of molecules, interferons, chemokines, lymphokines, interleukins, tumor necrosis factors are largely the five. Depending on what authors you read, you may see some additional families added in there, but for the most part, those are your core. And those all have different functions. And interestingly, they all have very different receptors. So they're very unique molecules that work in different capacities at different times under different signal transduction mechanisms, okay? Now, what cytokines are not, right? They typically are not growth factors, okay? They are not hormones. Now, there are one or two growth factors out there that have some immunomodulatory properties, and some authors and some folks will include those as cytokines. I have chosen not to for the sake of simplifying things. We'll get more into growth factors, probably not too much with the hormones, but we'll get into that down the road at some point, because they are important. Growth factors are very important in healing and repair and regeneration of tissues. But what's cool about cytokines is they're incredibly versatile molecules. They're relatively small. They're more peptides. They've got primary and maybe some secondary structure, so they're relatively simple. And they have very short half-lives. These are very potent molecules that can have profound effects. So the cellular environment maintains a very regulated control on their concentrations. I mean, you're talking picomolar concentrations that can have significant effects on the immune system. So some of the properties that cytokines have are important in how they function, and it's important to understand these properties to just really get a sense of the versatility of these molecules. So first of all, they're pleiotropic, okay? So what does that mean? Pleiotropy means that cytokines can engage a number of different cell types. Perhaps not all, but many different cell types. And why this is important is this allows many different cell types to communicate with the immune system. Okay, and the immune system to communicate back to those cells. So it's kind of a bridge property between our large cellular base and our immune system. So for example, if the cell encounters, let's say there's a fatal gene mutation, and then the cell detects this, it needs to communicate. It will upregulate particular cytokine production, send those messages out. Remember, proteins are the language of life, right? It will send those protein messages out, and those immune cells will respond to those signals and then make a decision whether to eliminate that cell, arrest the cell cycle of that particular cell, schedule it for an apoptotic type of destruction, what have you. So there's a multitude of different things. So pleiotropy is very, very important. And cytokines are also redundant. You have multiple cytokines that can do the same things in the same cells, or the same things in different cells. You have multiple pro-inflammatory cytokines that exert similar responses. They can be antagonistic. A cytokine can bind a receptor. For example, interleukin-1 is highly inflammatory. Interleukin cytokine, okay? But then there's another cytokine called interleukin-1 receptor antagonist that can bind those receptors and mitigate the effects of that pro-inflammatory cytokine. You can have one cytokine bind another cytokine and deactivate it. You can have another cytokine as the interleukin-1 receptor antagonist can cause changes in conformation of receptors, so the cytokine ligand can't bind to the receptor. Okay, so that is antagonistic. And then you've got synergy. Okay, so synergy means, as I'm sure most of you can figure out, that cytokines are working in concert. Okay, they may engage different receptor families and then go through a signal transduction pathway that leads to various effectors that potentiate the effects of a particular cytokine, making it a little more powerful, a little bit more meaningful. So, those are the four main properties. Pleiotropy is really the big one, but these properties really show you the versatility of the cytokines, and as complex as our immune systems are, you should have an equally complex communication system between our cellular bases and the immune cells. Okay? So how cytokines function, if you look at these diagrams, you get some sort of stimulus, okay? And I mentioned previously that could be, a gene mutation. It could be some sort of exogenous factor that causes damage in the cell. So you get an inducing stimulus. And what happens is the cell is going to, at the genetic level, at the nuclear level, is going to transcribe cytokine genes, okay, the appropriate cytokine genes. Those will ultimately be translated to cytokines. They'll then be released. And the objective there is to target a particular cell type and exert a response, okay? So the cytokine, you can see that it's released and it's going to bind receptors and cause a signal transduction event in that recipient cell, okay? And then that recipient cell is going to do what it does. It's going to alter its phenotype to take care of what needs elicit that response that cytokine is desiring. On the second half of this is really just a kind of a simplified model of intercellular communication. Autocrine action is when a cell secretes molecules and they kind of come back to that cell and stimulate that cell, okay? Then you have paracrine, okay, a paracrine modality where molecules may be released, signaling molecules are released, and they act on kind of nearby local cells. And then finally you have endocrine. So when I think endocrine, I'm thinking hormones. And hormones, as we know, can be released from our pituitary gland, but they affect cells throughout our body. The hormones released from our pituitary or our adrenal glands affect cells throughout our body. That is an endocrine modality of intercellular communication. Now, from the standpoint of regenerative medicine, we're really interested in the paracrine modality, because when you start talking about how stem cells manage their local environments, they're largely what they call paracrine effectors. Okay, so they're secreting cytokines or growth factors or other or extracellular matrix stimulating proteins in that local environment. So those are largely paracrine communications. So when you talk about regenerative formulations, we spend more time looking at how they communicate, how regenerative cells communicate locally, how they're managing those local environments. So what cells produce cytokines? Virtually all cells produce cytokines. And I mentioned this previously, cells need to be checking in with the immune system. If they're infected with a virus, they'll release certain compounds, maybe interferons, along with some interleukins and some chemokines to bring those cells in to start controlling immune responses and to start combating, putting themselves in a position to combat that particular infection. Okay, so when the cell needs a mayday or an SOS, it's using a lot of these cytokine families in various capacities to engage the immune system and get them to participate locally and assist them in ridding them of whatever event may be occurring. So just in general, these cells, again, going back to the previous slide, when a stimulus is encountered, okay, it's transcribed at the gene level, right? There's not a ton of cytokines just soluble in the cytosol, ready to go, because they have very short half-lives, and as I mentioned, they're very, very potent mediators, so they need to be tightly regulated, okay? So how do cytokines function? We've gone through this. You get a signaling. They bind membrane receptors. And I've talked about, I mentioned previously how each family has a very distinct membrane receptor system. And that leads to signal transduction. And I've talked about in previous talks about phosphorylation cascades and how ficitin controls those, as a supplement. But kinases and phosphorylation cascades are ubiquitous throughout our cell, throughout our cellular physiology, and is a prime modality for for affecting a response within the cell. And then ultimately you get transcription and ultimately translation of those cytokines. Those cytokines are then either secreted through exocytosis into the surrounding cytosol, or they may be packaged in an exosome and then released. So there's multiple ways that these cytokines can get out of the cell. Now, excuse me. Now, since COVID's been around, you've probably heard a lot of talk about a cytokine storm, and really it kind of is what what the name implies. It's a vicious cycle of extreme cytokine transcription and translation and release, and you have multiple factors that keep feeding back on each other in a positive fashion. So you keep growing this, you start creating this pro-inflammatory response, and it's not so much in the context of COVID. I mean, from what I understand about it, it's not so much the virus that causes the problems. It's your body's reaction to it. And if you have any type of comorbidity or pathology that's going to potentiate that, you're going to have some real problems. So the cytokine storm is just this vicious, positive feedback loop that just keeps that transduction signal on and that translation signal on, and more pro-inflammatory cytokines are produced, and you start changing the physiology of that microenvironment in the lung. You start accumulating fluid, you start decreasing gas transfer, the efficiency of gas transfer in the lung, and that's what's causing the problems. There are a lot of medications out there now that target specific cytokines and can bind those, but again, going back to the point, I said that these are incredibly potent little peptides and proteins, and a cytokine storm, when you're producing, maybe you get up to micromolar concentrations or, nanomolar concentrations, which, could be 10,000 times, what a normal effective concentration of cytokine might be. So that's really the genesis of the cytokine storm, to kind of put it into something that, we hear about in the news on a regular basis. Okay, so this is the crux. Why talk about cytokines? I wanted to talk about it today because they are so important in the success of many regenerative therapies that are available today. Controlling your inflammation, stimulating your endogenous cellular machinery, your endogenous cells to start waking up and start doing their job. The first thing you've got to do is get control of that inflammation. All of the pathologies that are potentially indicated for a regenerative or biological therapy, there's always a component of inflammation, and inflammation is not necessarily a bad thing. It does a lot of good things for our body in terms of tissue repair, healing, and regeneration, but when it's not controlled, okay, and when those stem cells, your endogenous cellular machinery, kind of goes to sleep in a hyperinflammatory environment. So what I want to do with a regenerative therapy is I want to bring biology in that is going to start to quell that inflammation, wake my endogenous cells up so that they can start doing what they were meant to do, okay? And we're going to keep talking about cytokines. You're going to hear me talk about them as we move into more complex areas of biological medicine. You're going to hear me talk over and over about cytokines, growth factors, and the like. So this was an opportunity to introduce them. All right, guys, I hope that presentation was semi-informative and gave you a good overview of what cytokines are, how they function, how they elicit their responses, so on and so forth. And most importantly, I want you to understand how important the cytokines are in particular regenerative formulations. So I wanted to do this presentation today to really set the table for what I want to do down the road. And that is take a deeper dive into some of the most important cytokines that you're going to find in a lot of regenerative formulations that exert a lot of positive effects. One, in controlling inflammation, but two, how they participate in the regeneration and repair of our tissues. So I look forward to those presentations. Stay tuned. Thanks for watching. Stay regenerative, my friends.